Hey team, is Mr. Z, and today we're going to do the opposite of what we did last time, which was turning radicals into rational expressions. Now we're going to go the other way. So let's go ahead and look at some fractional exponents and rewrite them. All right, so just the general idea is you have to remember that when it's x to, let's just say, a number, we'll say 1, and then the denominator is 2. What this means is the radical will have an index of 2, and that the term x will be to the first power. So when I go ahead and rewrite this first guy, it's going to end up being x squared to the third index times y to the fifth, the numerator, to the third index. Because these indexes are the same, because they're both in a cube root, I can actually combine them to rewrite it to be x squared y to the fifth. This next one is going to be similar, but I got to keep my grouping symbol. It is going to be the whole thing, a plus b, to the second power, to the fifth radical. Notice without that parenthesis, this would be incorrect. I need to raise a and b. The sum of a and b is to the second power. And then you apply the denominator of the exponent as the index. I'm going to go ahead and do the next one. It's okay if they have different denominators. The first one's going to be x to the first power, and it is to the square root times y squared to the third root. Now I can clean this one up a little bit. This isn't necessary, but essentially the idea is I can rewrite this as the square root of x times the cube root of y squared. Notice how when the exponent is 1, you can leave it out. It is assumed that if there is no index, that the index is 2. This final guy is just me dealing with a fraction. The first one is just going to be x squared, there is no radical, times y squared to the cube root, all over z to the first to the fourth root. And I'm going to clean this up to be x squared times my cube root of y squared, all over the fourth root of just z. So just remember that the denominator of a rational expression represents the index, and you'll be good to go. Practice this on your own. That's it for now.